Good morning, all. My name is Sridhar Prasad. I'm an assistant professor in civil engineering department. In this video, I'm going to deal with the concept called hydrology, which is a part of water resource engineering. So, water resource engineering is a subject in Department of Civil Engineering, and the course code is P12 CET 12. Okay, so now the hydrology, before introducing about the hydrology, let me get you to the course outcome which I have been dealing here. So the course outcome is to know the components of hydrological cycle and to estimate the amount of rainfall in a particular area. So let's get into the video now. Now whenever you see here, you have seen the name called hydrology. So whenever you see that name, the thing that comes into mind is hydro, which means water, and logos, which means science. It is a Greek word, derived from a Greek word. It is called as, look at this, logos means science, and hydros, which means water. So in this particular concept, we are going to deal with the water science, how the water comes onto the earth and return back to the atmosphere, and then how the water vice versa. Okay, so now the components of precipitation, sorry, components of hydrological cycle are precipitation, evaporation, evapotranspiration, infiltration, and groundwater, okay, as well as runoff. Now to deal with this, let us see what is the scientific definition of hydrology. The scientific definition of hydrology is, it is the science that deals with the movement, distribution, and circulation of water and physical and chemical components of the particular water. So it is completely related to the most valuable resource on the earth, that is water. Now let's get back to the hydrological cycle. So this concept has been studying from the 7th standard onwards. The teachers are giving the feed on hydrological cycle, but in this level of graduation, how the hydrological cycle is introduced to a graduate student, let us see. Now if this was an hydrological cycle, let us see, there are different phenomenons here, as you can observe, which has already given as quoted in the before, a minute before. So see here, so here we have a precipitation. What is precipitation actually? It is another form or another name of rainfall. Okay, precipitation is another name for rainfall. So rainfall can be of many types. Usually in a snowy area, we can observe the rainfall in the form of snow. In some other regions, dry regions, we observe rainfall as a water. In some other regions, we observe rainfall as a hail. Okay, based on the size of the droplet, we can give the name for that particular rainfall. Okay, so next we have a evaporation. So before explaining these topics, let us see how the hydrological cycle starts. If you have to take it from the beginning or you have to take it from the ending, let us take it from the ending. So now whenever the sun's rays falls onto this ocean, the top layer of the ocean water gets evaporated. Those evaporated water are carried out by the winds to form the clouds. Okay, whenever the clouds get heavy and due to some condensation process, automatically the clouds tends to release those water, and that water is called as precipitation. Okay, and those released water, whenever they're coming onto the surface of earth, they have to reach so many abstractions. Okay, the first abstraction is atmospheric heat, which is already on the earth. Second abstraction is the plants on the earth. Okay, so usually whenever you see the leaves of the plants are high, they absorb those water to the roots, or the scales in the leaves are tend to be very high, highly, I mean, they tend to be very highly absorbable. So this evaporated water comes onto the atmosphere, and that forms the cloud, and post condensation automatically they convert into precipitation, and this precipitation, when falling on the earth's surface, they will be abstracted by some trees which tend to absorb those water through the scales of the leaves, and when they absorb those water, the water regularly moves from the leaf scales to the roots of that particular plant. Okay, whenever these plants has absorbed required amount of water, the remaining water are tend to be evaporated again into atmosphere, and this process is called as transpiration. Okay, so if you have seen transpiration here, then now the evaporation has occurred, the plants has happily taken the water, and now they are moved to the earth surface. So let us suppose if the earth surface is completely dry or it is having very sunny day in the before, automatically what happens to that particular earth surface, it tend to absorb those water inside the ground surface, which is called as infiltration. Okay, so which is called as infiltration. So now if you see this infiltration process, where are those water goes after the infiltration? Simply goes into the groundwater table. Okay, this groundwater table, and then this groundwater again tend to move into the oceans, and now the earth has taken the water and the plants has taken the water. Now the remaining water which tend to be on the surface of the earth, this is called as runoff. Runoff. As per an engineer or as per an hydrologist, surface runoff is the profit of water, and the groundwater or infiltration is completely loss of water. How they have a variation this like this, if you can use those water instantly, then that is called as the profit. If you cannot use those water instantly, or you wanted to use, suppose let us take the groundwater table. Now the water goes into the earth surface, and when you can use it, when the aquifer reaches its maximum capacity, and after 10 to 15 years when you have dig a hole through a bore, then you can use those water for the past purposes. So according to the hydrologists, this is a loss. So now whenever you are dealing with hydrology, okay, whenever you are dealing with hydrology, runoff is our major concept, because those runoff water from the mountains goes into the lakes, lakes to the rivers. If the rivers has utilized it well used by constructing dams and reservoirs, then it would be happier, because we can improve the agriculture, we can improve irrigation for farmers as well as for the livelihood. But if you cannot use those water in the rivers, then automatically where the water goes to, then again into oceans, then evaporation starts and condensation starts, and the process gets cyclic. This cyclic process is called as hydrological cycle. Okay, now let's discuss the very most important concept of this hydrological cycle, is nothing but precipitation, or sometimes it is called as rainfall. Okay, so these are the components of and this is precipitation. So as we have spoken earlier, what is precipitation? Precipitation is the form of rainfall in any form based on the droplet size. Sometimes it is called as snow, sometimes it is called as rain, sometimes it is called as hail, sometimes it is called as dew. Okay, based on the droplet size, we have given different types of rainfalls. Okay, now let's get to the yes. So we have known this types and forms of precipitation now. Now let us go into the deeper of this concept, that is, these are the contents what we are going to discuss in this particular lecture. So we will be discussing about measurement of precipitation, next rain gauge networks, then estimation and estimation of missing rainfall data, as well as computation of average rainfall over an area. Now see, what is measurement of precipitation and why should we measure rainfall? And a lot of you have observed till today data, in the news, the weather news was given like this, the so-called place has this of rainfall, and the so-called place has observed this amount of rainfall during this hour, and the capacity, or sorry, I mean to say the depth of the rainfall is given in this particular area. So how they measure this rainfall? By using a device called as rain gauges. Okay, the rain gauges are observed in a place called as rain gauge stations. Okay, so we will go into this topic deeperly. Now see, so the measurement of precipitation is done by using rain gauges. Commonly in India, okay, the IMD, it is called as Indian Meteorological Department, suggests 4 types of rain gauges. based on the area requirements, as based on the lying of that particular area. So now we have seen here, first one is Simon's rain gauge, second one weighing bucket, third one tipping bucket, float or siphon type rain gauge. We can commonly called as, we can commonly called these two as non-automatic, okay, and these two as automatic type of rain gauges. So what is difference between automatic and non-automatic? Let us see now. Suppose if the so-called railway rain gauge station has been given on a plain area or somewhere around the elevation. Now the rainfall has started. If the rainfall has begun, let us see, automatically the container which has been placed over there starting absorbing those water. Whenever the container is full, automatically the water tend to be moving out. If the value is not recorded, then the container has to be taken care by a person, which is completely non-automatic. If the rainfall value is very high, or if the rainfall duration is very high, automatically what happens? Then the person has to go there, he has to change the water, and he has to empty that particular rain gauge, and he has to do the process again. This is called as non-automatic. So we have two types of non-automatic. The first one is weighing rain gauge, sorry, Simon's rain gauge, and second one is tipping bucket. So this is what is called as Simon's rain gauge. So now the name Simon came because he is the first one to introduce this type of rain gauge. Okay, as you have observed in this particular diagram, the rain gauge is placed on a concrete or cement slab, okay, which has an area of 60 centimeter by 55 centimeters. Now, as you observe here, it has a inner bottle as well as a funnel to collect the water. Okay, so whenever the rainfall starts, okay, automatically this funnel started collecting this water into this particular cylinder, which has a graduated scale outside it. The capacity of that particular funnel, I mean this cylinder, has been already provided. Okay, so based on these dimensions. So what is the basic disadvantage of this particular rain gauge? Earlierly it was used by IMD, Indian Meteorological Department, in the beginning of weather reports. But later on this has been taken out because there is a small glitch in this particular area. What is it? If the rainfall was more than this capacity, automatically a person has to attend there and should change the rain gauge or should change that particular bottle. It is not automatic, it is completely non-automatic type rain gauge. So that is why this has been later replaced with some other types of rain gauges. So we are going to next type, that is weighing bucket type. So the name weighing bucket, look at here, if you can see it, the name weighing bucket type has been already provided here. So it has a bucket which has collected rainwater from the funnel, and whenever the weight of this funnel increases or whenever the weight of this bucket increases, a spring mechanism is connected to a pen, and the pen is graduated on a graph, revolving drum graph. Okay, so whenever the weight increases, automatically this look at here, automatically these graph tend to observe the values here like this. Okay, so based on these values, and later on the graph is removed from that particular drum, and the values will be noted. Okay, now, so what are the major disadvantages here? If at all this weighing bucket is also high or this weighing bucket is also full, then the rainfall has to be recorded again, and sometimes it has to be destroy this particular revolving drum also. So later on they have introduced another types of rain gauges, that is third one, tipping bucket type. Tipping bucket type. So you have seen this diagram here. This is called as tipping bucket. So whenever the water falls onto this funnel, it has an automatic adjustment, and these 2 points are called as the calibration screws, which are attached to the electric impulse. Okay, electric impulse. So now if this bucket was full due to water, then automatically tend to get down, and again this bucket starts moving. So it is like a revolving mechanism. Okay. So whenever these water are high, automatically it are getting into the measuring tube. But again the same one came into the place. What is it? We have to change this tube automatically every time. Okay. So then, keeping in view of all these types of rain gauges, the particular person has introduced the fourth type, that is float type or siphon type rain gauge. So what is float type or siphon type? So as you have studied in the earlier physics classes, what is siphonic action? The siphonic action is that whenever a liquid and vacuum are filled in a particular area, if we tend to move that vacuum outside, automatically liquid also gets outside with that particular vacuum. Okay. So in this type of rain gauge, the vacuum action occurs. So now let us see. The funnel is very high here, sorry, very large diameter, and the water comes to fall into this rectangular box. Okay. Whenever this rectangular box gets into this particular float chamber, so automatically the float chamber water gets little higher. Whenever the water gets little higher, let us think the float along with the water gets to the top position. This float has very less weight. Let us take an example of cork. Okay, a cork sample has this weight. This is the cork sample. Okay, now whenever the float gets high, the pen connected to the float gets the values on this particular graph, the calibration graph. If what happens if the tank is completely full, this float chamber is completely full, then the siphonic action starts. How the siphonic action starts? Whenever this float gets to this position, automatically the water tends to move from this particular pipe. Okay, this is an exit pipe. This have doesn't do with anything with this particular inside chambers. Okay, so that the water gets peacefully outside, no need of a person to change it, no need of a mechanism to change it. Okay, so that's why it is a fully automatic type of rain gauge, and the siphonic action tends to take this type of rain gauge to be in lot of rain gauge station areas. Okay, till this, how do you know that what are types of rain gauges and what are fully automatic and non-automatic types of rain gauges? But how many rain gauges should be set in a particular area? We call the area in the hydrological terms as a basin. Okay, so we call a catchment area. So let us suppose we are in a college premises. This college premises comes under certain catchment area. So this catchment area has certain dimensions, and based on the dimensions we have to take number of rain gauge stations and their network should be set up. Okay, if the number of rain gauge stations are not adequate, there will be a a problem in noting down this particular rain gauge values. So as per Indian standard codes, these are the recommendations based on the type of area, how many types of rain gauges should be set up. Okay, so coming to the plain area, one station for every 520 kilometer square area. Okay, next for moderately elevated area, one station in 260 to 390 kilometers, because as the elevation increases, there should be some other stations to be noted that particular area. As the elevation increases, the rainfall values also changes from area to area. So that's why we are, and now hilly areas, one station in very and 130 kilometers radius, because the area is in a contouring type shape. So that's why we are increasing this particular number of rain gauge stations. So this is about the rain gauge networks. Now we are going to see how many number of rain gauge stations should be set in a particular catchment area. That is called as optimum number. So optimum number, which means the minimum number. Okay, let us suppose we are taking rainfall values in a particular area. So the particular area has minimum 10 stations, but every time whenever you are taking that particular rainfall values, the rainfall values you are usually represented in the form of graphs or the Excel sheet or a tabular columns. Okay, so if any one value is missing, what happens then? Automatically estimation misses. If the rainfall was very high in that particular area, automatically we cannot give the flood predictions, we cannot give drought predictions, we cannot give crop predictions. Okay, so whenever engineer has to study this course, has to keep in mind that he has been doing this all research, or he has been doing this all study and terms to evaluate the basic needs of a human being, as well as to overcome the upcoming dangers. Okay, so let us suppose if there is a flood in an area, and every time we will get a IMD's prediction that we will have this amount of flood in this particular area. So please get yourself from the oceans, rivers, and as well as some water resources, get far away from it. How they are giving this? Based on these rain gauge stations. Okay, so to estimate that particular rain gauge stations, we have this formula. Okay, it is called as n equal to Cv by E whole square, where n is optimum number of stations, Cv is coefficient of variation, and E is error. Okay, how much error has been noted? Okay, there will be sometimes 10%, 20%, but meantime the error should not be more than 10 to 15%, because if the error was more than 10 to 15%, automatically we can say that that particular rain gauge station has been failed of noting that value. Now see here, we will explain this term in detail. Okay, now coefficient of variance equal 100 into sigma m minus 1 by p bar, that is P bar is mean value and sigma m minus 1 is standard deviation. So P bar is equal to 1 by m into sigma of 1 to m, sigma variation from 1 to m. M is nothing but number of rain gauge stations existing. Okay, now we have to give the n value which has to be added for that particular area. So now this is a standard deviation. Okay, let us see an example to find a number of optimum rain gauge stations. Now see here, a catchment has 5 rain gauge stations. Okay, in an year, the annual rainfall recorded by the rain gauge stations are as follows. So we have a catchment area which has 5 rain gauge stations, and these are the rainfall values which are represented in the form of depth, that is mm. Okay, usually the rainfall is always represented in the form of depth, that is mm. So for a 10% error in the estimation, which means some rain gauge station has failed to record the value, that has given the final recording value as error as 10%. So now calculate the optimum number of stations in that particular catchment. So how do we calculate that? To calculate that, first you have to note down the given data. Okay. Now see here. How many stations are there? 5. M equal to 5. Next, we have these depths of rainfall here. Next, what is the error value? Which is E equal to 10%. Equal to 10%. Now from these values you have to find out the n equal to Cv by E whole square, optimum number of rain gauge stations in that particular area. So now to find out that, first you have to define Cv. So what is it we have discussed earlier about the Cv? Cv equal to 100 into sigma m minus 1 by p bar. So now as per this formula, first what should we have to find out? We have to find out the mean value, which is nothing but p bar. P bar equal to 1 by m is nothing but number of stations, that is m1 by 5 into next sigma 1 variating from m1 to m, that is how many rain gauge stations are there? Total 5 rain gauge stations are there. So you have to add those 5 values here, p1 plus p2 plus p3 plus p4 plus p5. Okay, so which is nothing but P1 is precipitation depth in that particular area. Let us see that precipitation depth. So it is 82.6, 102.8. So now the mean precipitation value, sorry, mean precipitation value, we have to write P bar equal to 1 by 5 of, what are the values? 82.6 plus, and so on. We'll find out these values and we'll write out the p bar value. Next, we'll write out a sigma m minus 1, which is nothing but the standard deviation. So these are the rainfall catchment areas. So as you have noted all the given data, let's go solve this problem now. So these are the rainfall values here. Okay, as you can observe, there are 5 rainfall values in here. 5 rainfall values in here. Now, first we have to find out the optimum number of rain gauge stations. To find out the optimum number of rain gauge stations, we have the formula called CV by E whole square, where CV is coefficient of rainfall. So that is defined as CV equal to 100 into sigma m minus 1 by P bar. Okay, where sigma m minus 1 is standard deviation and P bar is mean. So how the mean is calculated? P bar equal to sum of the total rainfall values by total number of rain gauges. So till the existing rain gauges are 5 and we have 5 rainfall values in here. Okay, so all these 5 rainfall values were summated and give that mean value we have 120.26. Next, we have to find out the standard deviation from this particular area. So to find out the standard deviation, we have a formula, that is sigma m equal to square root of pi minus p bar whole square by m minus 1. Here pi, the rainfall in particular area. Next, p bar is nothing but mean, which you already find out there, which is 120.26, and m is number of existing rain gauge stations, that is 5 minus 1 is equal to 4. As you have seen here, I have substituted all these values and I have to find out this standard deviation value, it is 20.27. As we have a mean and standard deviation, then we can find out the CV value also. Now to find out the CV value, we will substitute this formula and the coefficient is 116.85. Okay, so as you have find out the CV value, now substitute those values in this particular area. The optimum number of rain gauges n equal to CV by E whole square, where CV value is this and E is, which is a 10% error that is provided earlier. It is a 10% area error. So now on substituting this and solving this, we will get a 2.89, but the rain gauge station should be a rounded number. Okay, it should be a nearest rounded number. We cannot substitute a half rain gauge station or half rain gauge in a particular area. So that's why we are equated it to nearest rain gauge stations, that is number 3. So total optimum number of rain gauge stations in that particular area is equal to 3. This is how we predict the value. Okay, so this is about the rain gauge stations in a particular area. In the next coming lecture, we will discuss about average rainfall values. Thank you for today's session. See you in tomorrow.